Welcome to Team Chai's Operational Analytics Project for Business Administration 726, Spring Semester 2017. My name is Brittany Andura, and I am a member of Team Chai, along with Will Ely and Jeff Kalita. Thank you so much for watching our presentation today. This semester, our project revolved around operationalizing a predictive model. More specifically, we worked with ABC Company and their billing adjustment and call center data. We look forward to showing you our project here today. A bit of contextual background regarding our project this semester. Team Chai did have a professional relationship with ABC Company. And so this minimized the background research that we had to do because we already had a lot of knowledge built up. ABC Company specifically has a call center that we focused on, and that call center at the company allows customers to call in with inquiries. The staffing for that call center is based on a predictive model right now that does look at call volume and call length, but there have been a lot of unforeseen increases which have led to long queue times, or basically long wait times for the customer, and so they've had to increase their reliance on more expensive contract labor to help minimize the pressure on the call center. ABC Company does bill their customers monthly, and those bills occasionally have adjustment lines. So those adjustment lines are anything that are not standard on the bill. And so sometimes those lines can be confusing to customers, hence leading them to call into the call center for clarification. So the problem we really focused on had to do with those billing adjustments and the call center. So many management staff at ABC Company have assumed over the years that the spikes in call center volume have to do with billing adjustments. So the theory has always been that more adjustments on more customer bills leads those customers to call in and get some clarification on those adjustments before they go ahead and pay those bills. So anytime there's an unforeseen spike and contract labor needs to be pulled in, the assumption is, oh, we've had a lot more billing adjustments this month. But this hypothesis has never really been backed up by any evidence. It's not a part of their current predictive model for staffing their call center. It's just something that people have assumed at the company. So that's what Team Chai took on for this semester. We did a project to try to associate the call center and the billing data together and prove that assumption or that hypothesis and make a predictive model that includes billing adjustment data. The data we used when designing this was both the bill adjustment and call center data. So obviously we needed both pieces that were key to our theory in order to be able to prove that. So as you'll see in this presentation, we explored the data. We did a little bit of transformation, which we'll talk about. We tested our various predictive techniques to try and find the best model, reviewed our results, and then we're here with you today to present our findings. We acquired the data directly from ABC Company, and they provided us with 3 separate text files. The first was the billing adjustment file, which included things like each adjustment's amount, the date of the bill the adjustment appeared on, the month, and the state. And then we had 2 files with call center data. One was authenticated and one wasn't. So the authenticated file, each customer that calls in has a unique customer ID. And so that call was able to be tied back to a specific customer in their database. The all calls file is just all calls regardless of whether or not the specific call was tied back to a unique customer ID. And so those call files had things like the unique customer ID, or what we call the map ID, the date of the call, the topic, the duration of the call, and what state they were calling from. Specifically, the map ID is representative of a unique customer ID, but those customer IDs were masked by ABC Company before export. So we still have the unique ID that we can use to tie the 2 files together, but it's been masked, it's been changed into just a generic number for our benefit. And really all customer information was stripped from these files before ABC Company released them to Team Chai. So we can join on that map ID though to associate the billing and the call files together. We also have states in both files and dates in both files. Initially in our project, we did some data exploration just to get a handle on the data, look for any discernible or obvious patterns that may pop up, and try to plan our analysis with a little bit more education. So looking at the adjustment and call data here, you can see some basic statistics we were able to derive. So we looked at average adjustments, 1757.5, but we also looked at just Monday through Friday, just work days, and averaged that. You can see it's obviously a lot higher, 1780.3. And we did the same thing with the number of calls. So throughout the entire week, 713.9, but if we isolate just the 5 work days of the week, that average jumps to 722. We also found the standard deviations for those 4 categories, and for the work days specifically, we found the first and third quartile and the median. We also looked at things graphically. A lot of the time that allows for patterns to become more visible in sort of a visual sense. So we have our calls kind of mapped on a timeline here. We do have time series data with each of the colored lines representing a different state. And so you can see that there might be kind of a cycle here regarding when those call volumes spike, but overall it kind of seems to be a pretty consistent pattern for the 3 different states, and they kind of mirror each other to a certain respect, but there is this very, very large spike here at the end of the year. Similarly with adjustments, we can see adjustments seem to spike a little bit earlier than calls, but again, there could be sort of a cyclical pattern here, and we can see the entire year of 2016 mapped out for both of these different variables. We also took some averages for the month, so we averaged the call volume and the adjustment volume in this first graph, so how many calls, how many adjustments. And so the blue represents calls, the orange represents adjustments, and those are just the averages per month, so we can kind of see what the average pattern looks like there, and also kind of see that the two sort of move in the same shape there, which could maybe represent a relationship. And then with call volume and length of calls, call duration, we also map the averages. And again, we can see they kind of move in a pretty similar pattern, or maybe even almost overlap each other toward the end of the year. So we assume from here that maybe past months would mean that we have some reliable estimates for the future. So in our initial evaluation, not only did we have the basic statistics, but also kind of some patterns that may be emerging here that we could take a look at. Data transformation, there wasn't a lot of transformation that was really necessary in this project. We got full exports of the raw data. It was pretty easy to come up with counts and sums and make some basic transformations or derive some additional kind of variables based on counts and sums. And we were able to easily import this into SQL or use R. It was a lot of data, but those 2 tools were able to handle it pretty easily and allowed us to, get our counts and our sums and kind of some basic additional information out of the data. For the dates initially, we did make sure that they were formatted as dates, and then also split out additional variables like the month, the day of the week, the day of the month, just so we had those additional variables that we could test against. And then you'll see as we move into our final analysis, we did some more advanced transformations to try and get some better fits. We didn't need to resample the data. We didn't need to worry about class imbalances in our particular project, so we didn't have to worry about those too much. And for missing data, a couple of times when we summed up some numbers or got any averages, a couple of the beginning values, the first few days of our data were blank. So we just replaced those with averages, the average call handle time, the average number of calls just for the first 4 days of our data set. Initially, we decided, based on our preliminary analysis, to look at neural networks, random forests, and regression. So those were the 3 different methods we were going to try to produce a model for this call center. We assumed and kind of found that there was a large amount of data noise, so we thought neural networks would be good for that. With random forest, we were a little worried that all of the noise in the data could lead to overfitting, so we kind of kept that in the back of our mind as we approached that technique. But since there's so many variables and the speed of random forests are pretty quick, we were willing to deal with that trade-off. And then regression, just kind of looking for that linear relationship between the adjustments we had and the call volume. Be pretty easy for those at ABC Company to understand that model. because visually it's very easy to understand. So we were hoping that that one worked out as well. Further into our analysis, we also added on naive forecasts and moving averages to kind of take a look. You'll see that some of the models mentioned on the previous slides weren't a great fit, but these were also easy to explain and were a slightly better fit for us. So then we began our analysis and we ran a few different random forest models on both the all call data and the call data with just authenticated customer IDs. And you can see that, very concerning here, very obvious. The percent of variance explained was extremely small in both of those, 0.32% and 1.51%. So it was fairly obvious to us that these were not great models, that we shouldn't pursue developing these much further, because we couldn't get any, type of numbers or statistics here that really prove that this model was accounting for anything in the data at all. When we attempted to run some neural nets, the quantity of data and the lack of computing power resulted in most of the neural nets crashing mid-analysis. So just kind of based on those results, the neural nets really didn't work out as a model to pursue in our case either. And with linear regression, we didn't have much success here. If we kind of look at the results of one of the regression models that we ran, we can see that while the p-values for the coefficients and the intercepts are statistically significant, the adjusted R-square value is extremely small. So again, we're really not accounting for, any variance in the randomness in the model. This model is not a good fit for the data we have at all. And the best part of regression, we can just look at this visually and very clearly understand that if the orange line is what this model is predicting and the blue dots are the actual data, then this line isn't a fit. It's not really representing the actual data at all. Based on those intermediate results, there was obviously no sustainable or accurate model. We didn't get anything that we felt comfortable handing off to ABC Company and allowing them to use in their call center. We did decide that maybe some additional transformations could be helpful and make those models a lot stronger. And we also at this point decided to try naive models, try moving average models. Again, pretty easy to add on late in the game, easy to explain, easy and quick to run. But something else we hadn't tried, and that would maybe produce better results for us. So into our final analysis, we dropped the random forests. We decided not to pursue those since they were so unsuccessful. So although we were worried about having to protect against overfitting with that model, since we dropped that model, we kind of dropped the need to be concerned with overfitting like we were in that case. But we did keep linear analysis, and we used Rattle as a module of R to transform the data. So we did some log 10, natural log, recentering, and median transformations. And you can see here that the R-squared values did improve, the adjusted R-square, but not enough for this model to now be an accurate or sustainable model for our data. And then also the p-values of the coefficients. We could only ever get one of the two values we were using, call duration and number of calls, to be statistically significant in our linear regression model. And even when we removed the insignificant coefficient and reran the regression, it didn't improve the overall fit of the model by any means. And you can see here, just again visualizing the transformed data in the linear analysis, that again our red lines are really not a good fit for our data at all. So we moved on to our new theory regarding using naive analysis. And so you can see here for call volume, so the number of calls coming into the center, blue is actual, orange is estimated, and this is about the closest any of our models have ever been to actual results. And if we look at the call length, again, blue is actual, orange's estimate, we can see that this model is much, much closer, really with the exception of July and November in both models, where there seems to be an extreme difference between the two. If we look at the percent difference between actual and predicted for both call volume and duration again, we can see that we weren't off by very large percentages the majority of the time, but like I said, we can see here now numerically that July and November were indeed very far on the prediction from the actual result. Moving into a 2-month moving average, we can see that this one, the actual and predicted are even closer on our graphs, but November and July still proving to be problematic in both cases. And if we look at the percentages here, again, fairly small percentages of error, depending on if you feel 5% is small or not. But again, July and November, definitely very, very large differences that would be problematic should we implement this model at ABC Company. So after going through all of these different items, regression, random forest, moving average, naive, we found the best model was the 2-period moving average, but overall there wasn't a strong enough correlation between the call volumes or the call lengths and the number of billing adjustments. And especially problematic were July and November. Those large data swings in those months we could not account for, we could not predict better. And so that would be very problematic if we were to roll this model out. They wouldn't be any more accurate in staffing their call center, especially in those months. We were able to determine that most of the calls do occur Monday through Thursday, so a lot less calls on Friday. You could staff a little bit later. As an example, if we make some of these assumptions here regarding what the employees in the call center can work, how many weeks a month, minutes per hour they can handle calls, and then overall minutes per month, taking the estimates from our 2-month moving average model, we could determine that they would need 2,050 employees for the month. But as we know, call centers don't really schedule by month, they really schedule by day. So we would have to break this down further by day and make sure that our predictions were still accurate. But given the problems we still had with July and November, pursuing that even further really may not yield the best results still. So our conclusion that was the most functional model, our 2-month moving average, still wasn't acceptable for predicting call center demand. It wouldn't give ABC Company an accurate model to use so that they could reduce contract staffing, especially those 2 months that were problematic. They would still have a lot of labor costs there. The advantages of the model were it was really easy to explain. We didn't need a lot of computing power. It could be done very quickly and by someone who didn't have advanced analytic skills. But those large errors in those 2 months just weren't acceptable. They didn't make us feel confident in this model. We didn't get results that were strong enough where we would want to push ABC Company to replace their model. So while we didn't prove our hypothesis like we wanted to, we feel very confident in the analysis that we did and confident that even though it's assumed in the company that billing adjustments are leading to call volume, there may be other variables or something else that's leading to call volume. So if ABC Company is interested in proving a better predictive model, we've at least eliminated, for the most part, billing adjustments from consideration, and there may be other factors and other variables they should look at to make a better predictive model. So thank you very much for listening to Team Chai's presentation. We really appreciate your time today.